Okay, so we have already inserted our profile, and now the next thing we need to do on our very first profile is we need to set it up so that when we create other profiles in our drawing, that this profile will look good, and then we'll show you how to actually begin to draw pipes in it, or the profiles for the pipes. So what we're going to do next is we're going to go ahead and we're going to erase. There's a layer in here that's called the PB grid layer. I'm going to isolate that layer isolate by typing the command LAI, and I'm going to erase those because those are nothing more than the vertical interpolations of our surface along the alignment, and we don't need those to show up. Now the layer P grid should be set to a color like 254 or 252 or something like that. Now let's check to see what that layer is set to. It's actually set to 254, which is a good color, so we'll leave it at 254. Now the other thing that you need to remember is to double click your existing grade line, and you need to enable the line type generation. This allows the computer to actually enable the proper dashing of the line or serrations of the line so that it shows up right graphically. Now in these profiles you don't need the bottom elevation blocks here. These are sample elevations from the existing grade. I always erase those for storm drain profiles, and I also don't need the stations down there because the stations will we will not be using those stations. We'll be using stations that we create based upon the storm drain alignment itself. Okay, and you might always want to hit save, so we'll hit save after we've done a little work. And then the next thing we do, we've already taken the onus to go ahead and insert another profile that we can now use as a go-by, so to speak, as a prototype, and we can begin to match properties from that one. So I'm going to hit the match properties, and I'm going to turn my bottom line to dark blue from a vertical line. And then after that, what we're going to do is we can go ahead and copy the title, remembering to change the information at the bottom that we need to change. Now this particular structure right here, this profile, remember, is from stormwater management vault number 2 all the way down to manhole number 1. So what we'll do is we'll go ahead and edit that information. And remember, this scale for this one was 20, but now ours is 30. Okay. Storm water management, storm drain profile, we want to rename this one to stormwater management and storm drain profile. And we're going to call this from SWM Vault 02 to manhole 1. Okay. And we'll go ahead and extend this out right here like that. And because this drawing that we pulled this profile from was at a 20 scale, it's going to show up a little bit larger than the 30 scale drawing that we're creating. And so I'm just going to show up a little smaller, I'm sorry. So one of the things that we want to do is we want to go ahead and we want to scale that up a little bit. And we're going to look at the text height. And this is a L120. And one thing I know for the L120 at a 30 scale, the text height should be 3.6. And here it is actually 2.4. So we'll scale it up proportionally, and we'll do that by computing the scale factor. If I have 3.6 as a text height under the 20 scale, I'll just take 3.6 and divide it by 2.4 under a 30 scale drawing, and we need to scale this up by 1.5 times. So we'll just scale it by 1.5. Now that's properly scaled. Okay. The other thing that I failed to mention is that the existing contour layer, when you do these profiles for storm drains, will come up on this layer. The existing ground will come up on layer PEGC. And one of the things that you want to make sure you do is you want to go to that layer and make sure it's set with the proper coloring. And 252 is a good color. We like to keep that one. And -2 is a proper line type. Okay. All right. And then these text along here, along the side, they're set to a L80, and we typically like for those to be at a L120. And so what we'll do is we'll go ahead and set all of those to a L120. That'll make them show up a little larger, and maybe even an L140. We want that to stand out. Those are the actual vertical scale grades. You want those to stand out. So let's do something. I don't see the actual textiles in the drawing, so let's go ahead and go to projects, drawing setup, textile, and we're going to go to Leroy. We're going to load all those, and we're going to hit OK. Okay. And now when I select those texts, they should change. If I change them to an L, I should see the L40 first of all come up in our dialog box, and I do. And I'm going to change it. Now we're in good shape. Okay. The next thing that we're going to do is we're going to come in here, and we're going to, I'd like for these texts to show up just a little bit narrower, so I'm going to change the width factor to 0.85 for those. And then I also want to make some grid ticks along the side here. I'll draw me a vertical line with my ortho on, right? And then what I'll do is I'll copy the bottom blue line. Actually, I'll copy it, and I'll turn my snap on, so I can go to endpoint and use the intersection of snap. I'll copy that up to here, and then what I'm going to do is I'm going to trim it. Okay, so now I have actually some very good, I can copy this grid system all the way up, and I can do multiple. Copy those ticks all the way up the profile, and that just provides us a nice looking profile with some intermediate ticks to outline where, like for instance between 250 and 260, I know that this now is a 255 elevation right here. So one of the things I can also do is I will go ahead and copy this and actually label those. Okay, and I know that that was a 250 at first. I can come to my datum, I see that my datum is 240, so this must be a 245. Oops, put that back. 250, 255, 260, 265, 270, 275, right? So now we have a nice looking profile. We'll want to save that. Go ahead and save it. Great. Okay, so now the next thing that we would want to do, because the scale of this datum is actually too little, I'm going to go ahead and scale that using the end of the profile, Let me give it a 2 times scale so that it actually shows up with some, so we can see it. And now what we want to do is a whole different set of procedures. Now what we need to do is we need to go into the alignment, and we need to label the various stations along which we're going to have a storm drain structures. Okay, so in order to do that, I'm just going to switch my view back to the plan view, type the command plan so that I can work. And now you can see our X is horizontal and our Y is vertical. And then the other thing that we want to do now is change it back to world so that we're actually working in the user coordinate system, the real world user coordinate system. And what we're going to do, because we know that we're working along this alignment, the long one, now what we're going to begin to do is we're going to now begin to insert stations, station labels for that particular alignment. And so we're going to go in and say, we're going to say create station labels, and it's going to nope, we're not going to do that. We want to actually go hold on one second. Alignments and label. Here it is, label, station, and offset. There it is right here under the alignments command, station and offset, label. And now we want to keep our ortho on to intersection and endpoint, and what we want to do is we want to go ahead and put labels into our plan, which will guide us through our profile to let us know exactly where the end of our pipe start and begin and end, and the and where structures begin and end, and so forth. And so we're gonna put those in here. Hold on one second. I had my ortho on. I don't need it on when I'm doing this, and it came all the way down here to give me that. So I don't want that, and we're going to erase that because the ortho, I shouldn't have, my snap shouldn't have been there like that. So I don't want it to look like that. So what we're going to do is go back, erase that, and go back to alignments, station, offset, and label. From there, and take my O-snap off and my ortho off, and we'll put it there, hit enter. But the only problem now is that, as you can see, our labeling is in line with the worldview coordinate system. So what we want to do is we want to put it there, and I want to just test to see what happened. So I want to test and see what happens with the user coordinate system set to SWM03, which was it's not real world, it's just a regular user coordinate system that we created. I can almost guarantee that it's not going to give us the right station, and it may even tell us that we're not along the alignment. So let's label it, and let's come into here, and you see the point is not adjacent to the alignment. Why? Because the user coordinate system is completely off. So we must be in the real world coordinate system. Okay, and so what we'll do is we'll go ahead and keep it in the real world coordinate system, and we need to label those stations where at every point, like at the face of the structure, inside face of the structure, and we need to label it at the inside face of the structure. Okay, we need to label these at the inside face of the structure, again at the end of the pipes, but the inside face of the structures, and inside face of the structure. There you go. inside face of the structure once again, or the end of the pipe, whichever one it is. And then we're going to do the same thing here with the inside face of the structure, or the inside of the pipe in this case. And we're going to do this side of the structure as well, because we need to get a good look at what the width of the structure really is. And now we have our stations for the faces of the structures and the start and the beginning of the pipes. Okay. Now what we want to do is we want to isolate that layer along with the storm drain layer. And we're going to print this out, and this will be how we will draw our information on our profile. So we're going to print that out now. I'm going to print this using PDF just for the video sake, for the purpose of demonstration. And I select my plot device, and the plot device is going to be the Adobe. Alright, and what I'm going to do is I'm going to set the page size to D. Leave my scale at 1:30. Select a window here so we can capture our information. And hit preview, and I'm going to plot it. We have to make sure we click this thing because it's going to save the file. And so we just want to call this storm drain align stations. Call it outfall. Okay. Hit save. Now it's moving along to create our PDF. And our PDF is here. And so now we can see what our stations are as we work. You see it? And we're going to turn it around. Turn the view around, rotate the view. There you go. So now we can see what our stations are. Just like that. Okay, so what we see here is the first station at the face of the control structure inside the storm drain, stormwater management facility is a station 9.74. The second station is a 16.46 right here. Let's zoom in some so you can see it. See the first station right at the face of the wall is 9.74 at the face of the wall, 16.46. Let's go ahead and put those into our profile, those lines. Okay. We're going to turn it back to the world user coordinate system as well as the world view by typing the plan command. And this will put us back in the right coordinate system for our profile. Okay. And what we're going to do is we're going to set the layer to this layer. That is where the proposed storm drain layer is for this one. And what we'll do is we'll just draw a vertical line. Vertical line straight up like that, and that'll be the line that we'll use to offset to get to our structures. Okay. Go back to our PDF, 9.74 and 16.46. So we'll just basically offset 9.74. And we'll offset some more, 16.76, I believe. Let's double check. 16.46. Okay. So let's erase this. That line. Erase that one. And we're going to offset that to 16.46. Okay. Let's go back to our picture of our stations. Scroll down. Our next set of stations are 1 plus 58.48, which is 158.48, and 161.49. So 158.48 and 161.49. We'll minimize that. Offset 158.48. Offset 161.49. Okay, and that represents the structure right here, the structure right here. Now the next set of stations are station 211.71 and station 216.59. So 211.71 and 216.59. So let's get back to our drawing here, and we're going to offset this line at the bottom again. at the left again. We're going to offset this again, and we're going to go. The first distance is 211.71, and the second distance is 216.59. And now we have that alignment for that particular structure there. Go back to the PDF, and the last set of stations that we have are 456.75 and 461.25. Now it's important to note that the reason why I provided the PDF file was so that you can actually see on the screen what we were doing. But normally after I insert the stations, I'll just take a sheet of paper and I'll just write these stations down. And what I'll do after I write those stations down is I will then just offset those stations in the profile all at one time, just like we did just now. Okay, so let's do our last set and we're going to just offset 456.75 and 461.25. Okay, and then when we get finished with that, we'll just basically extend them all the way to the bottom of the profile. Okay. Great. Now we have the structures in the profile aligned vertically as they ought to be. Okay. We're going to hit save, type save, and we're going to save the drawing. Okay. Okay, so our next step now is to understand what our vertical scale factor really is. Okay, and we do that by coming into along the side of the chart, and we'll see what is the distance between the 255 and the 250. I believe it's going to be actually 25 feet because that's what we selected when we created the profile. So I'll just type DI for distance, and I'll go from endpoint of where the 255 elevation is and endpoint to the 250 elevation. And oh, what do we see? It's actually a distance of 30 feet, 30, and so a distance of 30 units. So what that tells us is that for every 1 foot of vertical profile depth, that it actually is 6 units, 6 offset units. So that if I were to offset this to 50 by 6, that would be 51, 52, 53, 54, and then finally 55. So we know now that this is 6 is the vertical scale unit factor. So all of our computations have to be based upon 6, because now we need to start setting in the inverts of these structures based upon the elevations that's given to you by the engineer. So for our first structure, this is the control structure, and we know that the invert of the pipe that's actually leaving the control structure, we know that that invert from our sketches and our drawings here from the engineer is, so that invert is actually 251.69. So basically, if I'm drawing this elevation at 251.69, then what I'm going to do is I'm going to come down to where the 250 is, and I'm going to draw myself a horizontal line to where the 250 is, just like that. And I need to go to 251.69. The way to do that is basically take the difference between 251.69 and the 250 right here, minus 250. That's 1.69, and then we have to multiply that times the 6, which is our vertical scale unit factor, times 6. We'll hit enter. So we need to offset this line right here by 10.14 units. And that now represents the exit point for our storm drain pipe. And we'll just put a circle there. Circle, intersection. And that becomes our exit point for our storm drain pipe. Okay? Now, the next structure that we go to, our invert for that structure is actually at an invert of 248. Okay? 248. So the way that we're going to find out how to do that one is we're going to basically come down to a 245. We'll draw a line, or we can start at the 250 and subtract 250 from the 248, which we should do that. Let's draw a line here at the 250 right there, and so we got to go to a 248. We know that our vertical scale factor is 6, so we need to offset this by 12. And then what we'll do is we'll erase that line so we don't get confused. And we'll extend that all the way to here, or you could just use a parent intersection. We'll draw a circle, and now we have the bottom of our storm drain pipe in our plan. There it is. So we'll follow this process all the way down the line. We got to have the invert. This is the invert in. We got to have the invert out, and the invert out for this situation, right, for this structure right here, structure yard inlet number 3, is 247.59. So we know that this point right here, where this circle is, where the center of the circle, the end of the pipe is at 248. Now the next line is the invert out of the structure, and that is at elevation 247.59. So we need to take the difference between the two, multiply it times our vertical scale factor, and then offset this line by that amount. So we're going to be going from a 248, and we're going to drop down to 247.59. So we'll get that number, 248 minus 247.59. And that puts us at 0.41. Now we have to multiply that times our vertical scale factor, times 6. So we need to offset this line by 2.46. units down. Okay. Now that becomes our new bottom of the pipe. And what we do, we always draw the bottom of our structures such that the structure itself is accounting, that's just that we account for the grout that we put in the bottom to go from invert in to invert out. Okay. Alright, so now the next thing that we need to do is we need to come in here and we need to find the invert for the next pipe, and that should be coming from your storm drain sketch from the engineer. Alright, and so the invert for the next pipe, let me take a look and see what our sketches say. So the next elevation for the next structure here is going to be elevation 244.28. So at manhole 2, the invert in the bottom of the pipe coming into manhole 2 is 244.28. So now what we're going to do is we're going to come down and we're going to grab our 245, and as you can see, we're running out of profile here, and so it's likely that we're going to have to extend it a little bit down further, which is okay. And so we're going to grab this 245 here, and we're going to find out what the difference is between 245 and 244.28, multiply it times our scale factor, vertical scale factor of 6, and that'll tell us what our offset distance is. Or we could actually literally take the endpoint of this point that we just made right here, and now we know that that elevation is 247.59. The only thing we have to do is go here into our calculator, we'll delete that, we'll type it in 247.59, and the next invert is going to be 244.28, so we'll say minus 244.28, and then we'll multiply that times our scale factor of 6, and now we need to offset that line by 19.86 units. Offset 19.86. Okay, so now this takes us to our next profile line from there to here, and we just use our old snaps, and now we have our line in. And the invert out of manhole number 2 is actually 244.18. Remember, this is 244.28, so that's a difference of 0.1. And so the only thing we'll do is we'll compute the difference, the offset difference, by going 0.1 times 6, and that's 0.6 that we need to go. So we'll just offset that by 0.6, and that tells us that this is the new invert. This is the point at which the pipe leaves manhole number 2. Okay, so now we'll just erase that, and the next elevation that we're going to go to, way down here at manhole number 1, the next one, that elevation is actually 241.13. So we're going to be going essentially from this elevation, which is 244.18, down to 241.13. So go to our calculator again, and we'll type in 244.18. We'll subtract the next elevation, which is 241.13. We'll multiply it times our vertical scale factor, times 6, that is. And that tells us that we need to be offsetting this line by 18.3 units. So we'll offset that by 18.30 units. Offset that down, And now we have only to connect the dots from there to there. Okay. Now we can erase these horizontal lines because these were just here to assist us, right? And we also can now erase these circles because those circles were there to assist us. So let's erase them. Because now we have the true bottom of our pipe. Alright. Now what we need to do next is we need to give these pipes some height to them. And so our first pipe, from the stormwater management facility to the yard inlet, that pipe is an 18-inch pipe. Okay, so that's 1.5 feet. 18 divided by 12 is 1.5 feet, and we just need to multiply that times our scale factor. And I'll show you. We'll just do it. 1.5 times our vertical scale factor, which is 6. So that's 9 units that we need to bring this up by. Now, something to really take note of is that this is an exaggerated vertical scale, and because of that, you can't just go offsetting. We can't just offset this line to get the height of the pipe. No, we can't do that. Everything is exaggerated vertically, so we're going to make sure that everything stays vertical. And the way that we do that is, we know we have to go 9 feet, is we always going to draw a horizontal line, keep our ortho on, and then we'll offset that by 9 units, I'm sorry. And then what will happen is we'll just copy this. Just like that. Okay. And then our next pipe is a 24-inch. This is a 24-inch RCP. The next one is. And so this one is a 24. So what we'll do is we'll draw us a horizontal line there. Keep your ortho on. And then we'll offset that because 24 inches is the same thing as 2 feet. So we just have to multiply 2 feet times our vertical scale factor. And so and that's 2 times 6, which means that we'll have to offset this by 12 units. And that becomes the top of our pipe, our 24-inch pipe. There you go. Okay. So our next pipe then is a 27-inch pipe. And the 27-inch pipe is the same thing that we're going to do. We'll just go ahead and compute what it is. 27-inch pipe is 27 divided by 12. It's 2.25 feet. And we got to multiply that times our vertical scale factor. That's times 6. So we need to offset. We got to offset units of 13.5. We got to offset it by 13.5. So let's draw our horizontal line, intersection here. We're going to offset that by 13.5. And that now becomes the new top of our 27-inch outfall pipe. Okay. So one of the things that we can do now is, because we're running out of profile here, and because this is going to be a drop manhole because we need to adjust the downstream leg, I'm going to go ahead and give us another 5 foot of profile down here. I'm going to show you how we're just going to simply do this by moving this down some. And we're going to offset this bottom line by the distance between 250 and 245. So we'll just let our distance be from there to there. And I will just offset this like that, and we'll go ahead and extend all of our vertical grid lines down. Okay, we need some more profile. And notice we're not moving the profile now. We're not moving the profile definition. We're not moving any of that, which is very important that we not do that, because if you move it, then you're going to have problems. You're not going to be able to use the profile tools. Okay. And then we want to use our match properties to change this line into the same properties as this line. So we'll match properties, click that, and now we've added more.
I'll take your salads ready.
Okay, so the next thing that we need to do now is we need to move the datum elevation block down and edit the data there. Okay, and we're going to select it. We'll go from endpoint of this grid right here to that grid point. And then, because this is all in attribute data, we need to type the command ATTEDIT, which is attribute edit. And now we can edit the 240, and now we know that that is actually 235.00. We'll hit OK, and now it's 235. And the next thing that we can do is come down and copy this. Change that to an elevation of 240. Okay. Alright. And we'll save our drawing now. Because we don't need necessarily all of this height for the profile here, what we're going to do is we're going to trim some of this off. We need to show all of the existing grade, but beyond, we don't really need all of this stuff right here. So let's go ahead and trim. We can trim a little bit of it off, but well, let's wait for that. We'll wait for that. Let's go ahead and extend these lines right here, which will be the lines that we use for our station data. Okay. Alright. And next, what we're going to do is we're going to go in and we're going to actually label. Something you need to know about the storm drain profiles is you always start from downstream in to upstream in with your stationing. So if I have some, I'll just go down here and I'll copy some of this text right here. And I believe we'll take a look at that and see what this is. Actually L100, which is a pretty decent text for what we need to do here with labeling stations. So I'm going to rotate that by, I just copied that text and I'll rotate it by 90 degrees and I'll move it down here. And I'm going to edit it. I'm going to call that station 0 plus 0.00. 0.00. How about that? And then what we're going to do is we're going to copy that to here. Put your ortho on. Copy that over. And now we can get the distance from this point to this point. And we got 240.16 feet. So we can edit that. So this will become 2 plus 40.16 feet. That's our stationing. That's how that goes. And now what we're going to do is we're going to come in here. We're going to copy this one again. We'll put it there. This is now the station 0 for the next segment of pipe. And now we're going to get a distance from this face of the storm drain pipe to this face of the storm drain pipe. And we do that horizontally always by going there. And we got 50.22. So what we'll do is we'll copy this and we'll go there, just like that. And it's 50.22, so we got 0, 50, 22. So station 0 plus 50.22. And now we'll do the same thing. We'll copy, because now we're going to go from 0. That's how they build storm drain, from downstream in to upstream in. And now we'll come down here and we'll copy this and to this side. Now that becomes 0, and we'll measure the distance between this and that. And now that's 142.02. So we'll go ahead and copy this to there. And 140, let's measure that again, 142.02. So it's 1 plus 42.02. There you go. Hit save again. Now we have our stations in there. And the next thing we need to do is we need to trim these off based upon the top of the structure that we know that we have. And so we'll pick that up in a few moments. Okay, so now we want to actually find out what the top of each structure is, and or the ground where the structure is. And then we're going to move forward with cutting the tops of these structures off, and then we'll label the tops of them. And then we have some data that goes inside each, in between each structure, and we'll just show you how we're going to do that. Okay. So at manhole, this is manhole 1, manhole 2, yard inlet number 6, and then this is back over to the stormwater management vault. So what we're going to do is we're going to start with yard inlet number 6, and let's see what the top of that structure is. Top of the structure at yard inlet, actually this is yard inlet number 3. Top of structure at yard inlet number 3 will be somewhere around about 253. So we're going to go ahead and cut it off at 253. And we know that our unit scale is 6. So 3 times 6, if I draw a line here to 250, that will be 18. We can offset that 18, so we'll draw a line at the 250, offset it 18. Oops, offset it the other direction. Okay. And now we'll be in good shape. Do this way. And that's our, oops, let's not do it that way. Let's just trim this. Okay. And now let's move to the manhole number 2, which is out in the street. Let's find out what that elevation is in that area, because we want to keep the grade in the road about the same. So we'll come in here, and we want to keep the grade right at the existing grade. And what we're going to do in here is go to terrain, or no, we're going to inquiry, and we're going to go to surface elevation. And I need to know what the surface elevation is. Turn the snaps off. And that's 253.71. Actually, let's get it at the manhole lid. Same, 253.73. Okay. So 253.73. for manhole number 2. So we have to go 3.73 above the 250. 3.73 times 6, 22.38. I'm going to offset this, 22.38. There you go. And then we're going to extend it all the way over to the manhole number 1, and we will trim it. There you go. The next thing we're going to do is let's find out what the elevation of manhole number 2 is, and go over again to the where we're inserting manhole number 2. Place your cursor right above the storm drain cover, and you go to your inquiry, surface elevation, and put it there. And that's 250.67. 250.67. Okay. So if that's 250.67, then we come over here, and we know that we're at 250 here, so we'll go 0.67 times our vertical scale factor. 0.67 times 6. So we're going 4.02 units of offset from the 250. So offset that, 4.02. And we can extend that all the way down to the end of that structure, right there. And you know you're in good shape when you see that your existing grade is actually lining up pretty well with what the top of the manhole is. That means that everything is in good shape, and it's coming out the way that it's supposed to come out. Okay, so one thing that we need to do next is we need to go ahead and trim the tops of these structures. We'll trim them now. And then we need to save it. There you go. We've saved it. And now we can also trim the bottoms of these structures, and we do that by placing a line beneath them. And this one I'm going to hold off because we need to get the bottom, the invert of this structure. This will be a new manhole, but it will need to take into account the existing storm drain pipes that are there. So what we're going to do is deal with these for now. We'll trim. Now we'll do that. Trim. Then the other thing that we do, we don't like to show our pipes. We show them like that. This is how we show them. Okay. And now let's determine what the bottom of manhole number 1 will be. What we do know from our design notes is that there's an outfall for manhole number. We're going to be outfalling at this elevation here, which is, if I go to profile list, spot elevations. So we're going to be outfalling at 241.13. However, the actual outfall pipe for this is going to be a little lower than that structure, and it's going to be 241. That's where we're going to take ours out at 241. Because there's another pipe that flows into this at 243. and that pipe is coming from the south. Okay. So what we're going to do, this is very important for you to pay attention to this. This is how we draw our structures when we have multiple pipes coming into the same. And so the outfall pipe for this manhole is going to be at 241. While we have this being at 241.13, we need to drop down 0.13 feet. So we'll say 0.13 times 6. 0.78 is the offset distance. Offset 0.78. And now we have go to intersection. Now we have the bottom of our storm drain discharge pipe at manhole number 1. Okay. And this pipe is actually a 30-inch RCP that discharges out of it. So 30-inch RCP. And we just need to show it. 30 inches is the same thing as 2.5 feet, so we go 2.5 times 6, 15 offset units. Offset is 15. And that's the top of our pipe. Okay. And now we need to draw the end of the pipe. And we come here, and then we do some type of arc. Just like so. Then we do another arc. Because we don't want to show all of that pipe. We just want to cut it off and keep it moving. Alright. Now there's also another pipe that comes in, like I said, from the south. And it's a 30-inch pipe. And it's at elevation 243.22. So if I'm at elevation 243.22 and this is a 40 grid line right here, and I need to take 3.22 because it's 3.22 above the 240, so there's 243.22, so we'll say 3.22 times 6 is 19.32, and that's our offset distance, 19.32. We'll offset that. That becomes the invert of the inflow pipe to this manhole number 1 as well. Now we know that this is a 30-inch RCP, which is 2.5 feet. So 2.5 times 6, that's 15. So we offset this by 15 units, offset units. And then we can draw an ellipse. We can draw a line first. If it's 30 inches, that's 2.5 feet. So we'll offset this at 1.25 each. Okay. And we'll trim it. And then we'll do an ellipse. And point. And they will hit the midpoints of the sidelines. And now that represents a truly exaggerated 30-inch RCP. And we'll just take that and move it with our ortho on. We'll move it into here. And that becomes a 30-inch RCP coming in from the south. Okay. Make sure we hit save. And now I would say we need to do one more thing, and that is we need to set the bottom of the structure. If the invert of that pipe is 241.13, right here, the discharge pipe, then we'll let the bottom of it be about 3.5 inches, 4 inches actually. Well, we probably should check in our concrete pipe design manual booklet, and we see for a 30-inch RCP that has a wall thickness, maximum wall thickness, or minimum wall thickness of 4.25. So 4.25 inches is the minimum. And what we'll do, we'll go ahead and convert that to feet. 4.25 divided by 12. That's 0.354, and we need to multiply that times our conversion factor times 6, and we get 2.125, and that should become the bottom of our structure. 2.125 below the invert of the pipe. Now we have the bottom of our structure. And we'll trim that. And now we have a storm drain pipe that truly, a structure that truly represents what we want to convey. Okay. And that, oops. That's how we put our profiles in. Now obviously we're not done, so we still need to now go, we need to label all this stuff. We need to put our proposed grade in. We need to do a lot of different things now. And so there are a number of ways to put a proposed grade in. You can put it in if you have a surface. You can put it in by using the digital terrain model. You can put it in and just bring the surface in. And I think that's what we're going to actually do here. The only problem is I have not finished with the proposed grade surface as far as creating one. We put the grades in, but we have not created a surface yet. So we'll do that here in a minute, and then we'll be back in a moment.